Alright, so first of all, what is a polynomial? Well, polynomial is any function that has the form where x is raised to a positive integer. So whenever x is raised to a positive integer, and there can be many of those, it's a polynomial. So something like x cubed plus 3x squared plus 4x plus 3, this is a polynomial. Anything like x squared plus 4x plus 1, this is a polynomial. Now, in a polynomial, there's a certain x whose power is the highest, and the highest power of x is the degree of x. So in this case, this is a degree 3 polynomial, or we also call this a cubic, right? Here the highest power is 2, so this is a degree 2 polynomial, and we call this a quadratic, and this is what we will talk about. And so a quadratic is anything that is in the general form of ax squared plus bx plus c, right? So in this, b can be 0, c can also be 0, but a cannot be 0, because if a is 0, then the highest power is either this or this. So to give you an example, 3x squared plus 4x plus 1, this is a quadratic. Oh, I think I said polynomial. This is a quadratic. So 3x squared plus 4x plus 1 is a quadratic, and 3x squared plus 1 is still a quadratic, and 3x squared plus 4x is still a quadratic. But if I remove the 3x squared from here, let's say 4x plus 1, this is no longer a quadratic, this is a linear, right? Now, this is one form of representing a quadratic function. Another form would be the completed squared form. So let's write a heading over here, completed squared form. In a completed squared form, you express the function in this form: a x minus b squared plus q, right? And what you really do, the reason why it's called a complete squared form is that notice how we have compressed it into sum squared times sum a plus some constant, right? Okay, so what you would probably already know is if I have something like x plus a whole squared, when you expand this, you get x squared plus 2ax plus a squared. And so if I have anything like px plus a, or actually let's take the same thing, ax minus p whole squared plus q, you can easily get the standard form back by expanding. So a x squared minus 2xp plus p squared plus q, once you expand this, you get ax squared minus 2axp plus a p squared plus q, and we got our original form back. What we will further look into this is, if we have been given our usual form, how do we go to the complete squared form? And already you can probably see that if we just compare this to this, we can get the coefficients. As in, if we've been given this part, we can easily compare the coefficient, but I will show you an easier way to do it. So let's take something like 2x squared plus 4x plus 6. The very first thing that I will do is I will take the 2 as common. So 2x squared plus 4x, and I have a choice. I can either write the plus 6 over here, the plus 3, this should be a 2 because we're dividing. I can either write the plus 3 over here, or I can close the bracket over here and write plus 6 here. It's the same thing. Now what we do is, look at the x term, look at the coefficient of the x term, divided by 2 and then square it, right? So I just took the 2 divided by 2, I squared it, and I added it. And since I've added something, I must minus it also something, because in order for it to remain the same function that it was. So plus 1 squared minus 1 squared doesn't change the function, close the bracket, plus 6. Now why did I do this? The reason why I did this is because we can recognize that this is a complete square, because anything like x squared plus 2ax plus a squared is the same as x plus a whole squared, right? So in this, I had x plus sum 2ax, what I did was I took that 2a, so sorry, this would be x squared plus 2ax. I took the 2a, I divided by 2, squared it, and then added the same thing. And so this portion is just x plus a squared. Right, so what I can do is I can compress this part into a whole squared. So x plus, well, 2 divided by 2 is 1, x plus 1 whole squared, and then I still have a minus 1 squared, which is just 1 plus 6. Right, so I just take the minus 1 out, so x plus 1 whole squared, 2 times x plus 1 whole squared, plus 6 minus 2, and so we get our complete squared form, plus 4. Right, now just to give you another example, let's take minus 3x plus 4x plus 9. This is example 2. Now, as usual, we take the coefficient as common, and what you do is you take the whole thing as common, as in you take the negative common too. So negative 3x minus 4 over 3x, and I can sort of compress these two steps into one, so I will just leave some space here and then a plus 9. Right, so now I take this coefficient plus and I divide by 2, so 4 over 3 divided by 2 is 2 over 3, and so it becomes negative 2 over 3 squared. Since I've added something, I subtract the same thing squared. Right, notice how this negative sign goes along into the brackets, and once I compress this, so this should be a squared. This whole thing can be compressed into x minus 2 over 3 whole squared plus a 9 minus 3 times minus 4 over 9. Right, and so I get minus 3x minus 2 over 3 whole squared plus 9 plus 4 over 3, and you can just add them up and you will get the answer. Right, so we looked at how to convert to complete squared form. We talked about why it makes sense, and so in the next video we'll look at the use of complete squared form. In other words, we'll look at how to sketch quadratics. Right.